BA Honors, Psychological Research, PSY 05. Hello friends, good morning, how are you? I hope you will be fine and must be enjoying the series of lectures on psychology. Since this paper is dealing with the research methodology, and in research methodology, when we say research is a systematic process. There are certain steps, systematic steps. First you have this, then that, then that, then that. So as long we go on doing the research. For example, when you do the research, first of all you have the problem. After problem, selecting the problem on whom you will work. Then you make a hypothesis, which is a tentative solution of the problem, that is called hypothesis. Then to test the hypothesis, you must need some tools and techniques, observation, experimental method, interview, case study, like that, focus group discussion, survey method, what not. These are the methods. But now the question is that on whom you will collect the data. After all, you are dealing with a problem, you want to study the effect of the new education policy on the young student, on the younger generation. Now, from the younger generation on whom you will study, this is the problem. So, this problem is called is the problem of the sampling. So, when we talk about the sampling, there are two concepts which must be clear to you, absolutely crystal clear like water should be clear to you. First is the population and second is the sample. Population means totality, and the part of the totality which we take for the study, for the data collection is called the sample. For example, as a layman, forget about psychology, research method, come to a general example. When we have some problem, body problem, we have the fever, doctor says that go and take your blood tested in the pathological lab. We go in the pathology lab, and here the doctor takes only 2-3 drops of the blood from your body, and then he or she studies it and then tells whether there is infection or not. Now, if there is infection in the 2-3 drops of the blood, that means there is an infection in whole of the blood. My blood in the body is the population, and 2-3 drops which I have taken for the study is the sample. So, that means the result of the sample is generalized on the population. You might have seen cooking the rice in the house, your mama, grandmother, your sister, boiled rice. Now, what mother or the grandma does? Now, after some time when there is a boiling, the rices are boiling, now she takes only one particle of the rice and tries to see whether it has been cooked or not. If one has been cooked, that means the complete rice of the utensil has been cooked. That means the whole rice is the population and the one which I am testing is the sample. Similarly, this problem arises in the research method when we come to the psychology or the social sciences. I want to study that what is the attitude of 20-year-old college students of a city towards a particular policy. Now, there may be 5,000, 10,000, 4,000 students of the age group 20 in that city. Now, is it possible for me to study all the 20,000 students? If I do it, it is time consuming, it will be more money consuming. So, I must have some sample from that. It is called the problem of the sampling. So, today we will talk about that how we can collect the sample from the population. If the sample from the population is collected properly, it is truly representative of the population, then the results can be generalized. So, I think the concept of the population and sampling is now very much clear. So, population is the total, and the part of the total which we take for the study is called as the sample. Now, let us start. The terms need attention in understanding the research in psychology. Number 1, population. Number 2, sample. Population, the total or entire domain being studied, as I have told you. Sample is the part of population selected for the study. It is not possible to study the entire population, So sample is taken. It is just not possible to study 20,000, 50,000, 1 lakh, the population may be 1 lakh. It is not possible. So we take the sample. A good sample is that which represents the population and free from bias. Sample selection can be divided into two categories. Now, if the sample which I am taking, I am selecting is biased because of me or some other factors, then it cannot be the representative of that population. If it is not the representation, not representing the population, how you can generalize the result which you are getting from the sample for the population? So a good sample is that where the biases don't appear, which is an objective type of the sampling. Now, there are two techniques of sample selection. One is called probability sampling and the second is called non-probability sampling. So let us talk about all these techniques. First of all, we will talk about probability sampling. Probability sampling refers the selection of a sample from a population when this selection is based on the principle of randomization, that is random selection chance. Probability sampling is more complex, more time consuming and usually more costly than the non-probability sampling. However, because units from the population are randomly selected and each unit selection probability can be calculated, reliable estimates can be produced and statistical inference can be made about the population. Though there are two types, probability and the non-probability. The probability sampling which we will talk about today is time consuming. It takes the time in comparison to the non-probability. Non-probability is just convenience. I will tell you technique, whosoever is available I take, but here I will have to adopt a certain strategy. Though probability is a time consuming, but it is better. Why it is better? Because it is free from the biases. The results which we are getting from the random sampling, we can better generalize the result from the sample to the population. So let us start probability sampling. Methods of probability sampling. There are several different methods in which a probability sample can be selected. When choosing probability sample design, the goal is to minimize the sampling error of the estimates for the most important survey variables while simultaneously minimizing the time and cost of conducting the survey. The probability sampling techniques are discussed below. Now, what I have said, which I just told you, the best method or the maximum advantage of this method is that the biases are minimized, the error will be minimized. So, though the error is minimized, but it should be conducted in such a way that it's become economical in terms of the time and as well as the money. So, how we'll talk about the techniques. First technique of the probability sampling is called random sampling. The descriptive term random is often misunderstood. It does not imply that sample has been chosen in an often careless or haphazard fashion. Instead, it means that we rely upon a certain method of selection called random to provide an unbiased cross section of the large group of the population. Now, here sometimes the confusion occurs. When we say random sampling, the random word means haphazard manner, haphazard, no order, here, there and there. If you go, you sitting in your drawing room, now there are 20 chairs, the systematic is that one chair, second, third, fourth. Now, haphazard means one in the right corner, second in the middle, third in the left corner, fourth in the next corner. So, this is a haphazard manner. Now, when we say random sampling, it doesn't mean haphazard. It has certain conditions and that conditions must be fulfilled for the random sampling. Now, what are those conditions? Now, criteria of random sampling. These two criteria of random sampling must be fulfilled. There are two basic criteria I will talk about, I will explain, and these criterion must be fulfilled. If these criteria is not fulfilled, then the sample will not be called as the random sampling. Now, first is every individual in the population has the same chance of being chosen for the sample. Every person, every individual of the population has equal probability of being selected in the sample. If there are 5,000, number 1 can be chosen, number 2 can be chosen, and number 5,000 can also be chosen. Then every individual in the population has the same equal chance, equal probability, first condition. Now, second, selection of one individual or thing in no way influences the selection of the other. That means, if selection number 1 is selected, it will not influence the selection of the other number in any way. For example, let us take a very small example. Now, I have population of the 100. Now, I have to choose sample of the 10. Now, sample size is 10, population is 100. Now, random sampling means everybody has equal chance. 1 can be selected, 90 number can be selected, 50th can be selected. Now, suppose, now how that will come, we will talk about technique. If 1 is selected, it does not mean that roll number or serial number 2 will be rejected. If 1 is selected, 2 has again equal chance of being selected. So, that means everyone has equal chance, equal probability, that is why it is called probability sampling. And number 2, selection of 1 will not affect in any way the selection of the other. To meet out these criteria, number of methods can be used like lottery method, rotating drum method, nth number, etc. Now, I will just explain you this method. A clear distinction should be made between representativeness and random sample. A representative sample is one in which the distribution of score in the sample closely parallels that of the population. So, that will come upon when we will talk about the error part, its error component. Now, first let us talk about, I have said that methods can be lottery method, rotating drum method, nth number, etc. Now, listen carefully. Lottery method. Now, what I do, population is 100, I am to select only 10. So, I make the slip 1, 2, 3 as you do in the lottery number method. Now, roll number 1, serial number 1, serial number 2, or you can put the names and put the 100 slips in a bucket. Now, you ask any person, any child, anybody, he comes or she comes and she picks only 10 slips because sample size is 10. Only 10 slips out of 100. Now, those serial number which will be selected will consist of the number or will consist of my sample. Now, if serial number 1 has come, equal possibility that the slip number 2 may be picked. 1 has been come, it is probable that number 100 may be picked up. So, lottery method is one of the best method where you can use the random sampling. The second I have told you, rotating drum. Now, technology has come, we do lottery system by the computer generates the number. Earlier you might have seen in some serials or you might have seen earlier lottery systems, there were rotating drums. Now, there is a big drum where the numbers are written 1, 2, 3, 4, 5, 6 and there is a needle. Now, you will rotate the drum, the needle will move. Now, if the needle stops at point number 5, that means the serial number 5th will be selected in the sample. You again rotate the drum, it stops at number 1. Number 1 will be selected, again rotate, it stops at the number 20th. Now, 20th will be selected. So, lottery and rotating drum may be another method. Third method I have talked about is nth number. Nth number means you provide me the list, I do not know anybody, you have just given me the number 1, 2, 3, 4, serial number 1, 2, 3. Now, I say neither I am applying lottery method nor I am using the rotating drum method. I say every 5th, n means number 5th, 5 is for the n. Every 5th will be my sample, 5th, 10th, 15th, 20, 25th, go on. Now, I say every 10th will be my sample. Now, out of 100, I have to take 10th, 20th, 30th, 40th, 50th, like that. So, this method is called as the nth number method. So, if you see lottery, rotating drum or the nth number, everybody has equal chance of being selection and selection of 1 will not affect in any way the selection of the second or the other person. So, these are the methods. For the another method I will talk later on. A representative sample is one in which the distribution of scores in the sample closely parallels that of the population. That means, representative sample will be that where it will be number, the mean will be, rather you can say, will be equally, it cannot be just almost the same, but it will be equally parallel to the mean of the population. Experience has shown that if one is asked to get the representative sample from the population, he will, for various reasons, some even not recognized, just we do not know, any reason may emerge, often draws a sample which exhibit consistent bias of one sort or the other. Now, there is a possibility, though we are taking full precaution in nth number, in lottery method, rotating drum method, but still there are possibility that some error may emerge. Now, what is that error? How you will calculate? We will talk about. The most trustworthy way of securing representativeness, therefore, is to make sure that sample is random. If we draw sample at random from the population, we know at least there will be no consistent bias. Number 2, on average these sample will be representative, and number 3, the degree of discrepancy likely to occur in any given sample can be determined by probability method. Now, the standard error of mean can be calculated by the formula. Standard error mean is equal to SD upon under root n. SD is the standard deviation, n is the number of cases. This standard error mean will tell us that what is the extent of mean while assuming sample mean equal to the mean of the population. So, if the sample is more representative, the value of standard error mean will be less. If it is not representative, the error will be, standard error mean will be more. Situation with the drawing of a random sampling, where you can draw. In research problem in psychology and education, mainly two situations arise in connection with the drawing of a random sample. A, the members of the population are on a file or have been catalogued in some way. I have told you 1, 2, 3, 4, 5. Number 2, the form of the distribution of the trait of the population is known to be normal, it should be normally distributed. These situations are discussed briefly. A, members of population are on a file or catalogued. If the population has been properly listed, a type of systematic selection will provide what is approximately random sampling. One method is nth number, thus we may take every 5th or the 10th depending upon the size of the sample wanted. In a long list provided, names have been put in a alphabetic order and are not arranged with respect to some different factor such as age, income or education. You put the name in the alphabetic order, then I will say every 5th name I will take, but if you are putting on the aspect income, age, education, then it may be bias. Now, number 2, use of, how we can take use of random table, this is other technique, nth, lottery, rotating, other technique. When the subjects in a group are to be assigned at random to one or more experimental or the control subgroups, tables of random numbers may be used. In such tables, numbers are arranged by chance procedure and are printed in reference. 10th block of 25 number I have taken from Fisher and Yates table is represented in an example. Now, this table I have taken is given by Fisher and Yates. Now, they have given a table, you see 1, 2, 3, 4, 5, 5 series column, 5, 5, 5, 5. So, these are 1, 2, 3, 4, 5, 25. Now, I have to take, suppose this is actually number of the population. Now, I will say the number which are appearing I will choose in my sample. 34, serial number 34 in my sample, 85 in my sample, 9 will be 88, 90, 50, 22 or 34. Now, after you just leave one, 9, then leave 88, 90, leave 50, 22 like that. So, if even we use that random tables given by Fisher and Yates, or you can form your own, the sample will be called as your random sampling. Distribution, number second condition, distribution trait in the population is known. As a result of much research in individual differences, many physical and mental traits are believed to be normally distributed or approximately so in general population. If a trait or ability in which we are interested is known to be normally distributed in the population, a sample drawn at random from this population will also be normally distributed. Hence, under stipulated conditions, normality of distribution becomes a good criterion of sample adequacy. That means, a sample will be representative when you will use the trait which you are measuring is normally distributed. Normal distribution is another topic, separate topic we will talk about in detail somewhere in statistics, and number should be catalogued. So, this was the first technique about the random sampling. The second technique is called stratified random sampling. Stratified or quota sampling, also called controlled sampling, is a technique designed to ensure representativeness and avoid bias by use of a modified random sampling method. The scheme is applicable when the population is composed of subgroups or strata of different sizes, so that a representative sample must contain individuals drawn from each category or stratum in accordance with the size of the subgroups. Within each stratum of subgroup, the sampling random, it can be explained with the given example. Now, what is stratified? Population may be of two types, homogeneous, heterogeneous. Homogeneous means when the population is of the same equal category in all respects. Heterogeneous means when the population is in the different subgroups in the strata. Suppose my population is arts students of a college, and in that college there is only faculty of arts, there is no science, no commerce. So, population is arts, there are 1000 students, and I have to take 200 the sample. Now, this is a homogeneous population. You can use lottery method, you can use nth number, you can use random table, you can use statistical table method, any method. Sometimes the problem comes when the population is heterogeneous. For example, now in my population in the college, university, where I am going to further research, further study, now try to see, there are art students are 400, then science faculty has 300, commerce faculty students are 100, and law students are 200. Now, total sample is 1000. If you add it up, it will come 1000. Now, I want sample of only 100. Now, if I adopt, try to understand, if I use lottery method, so I have put 1000 slips, putting the names or the serial number, and then start picking up. Can we deny that though I am using lottery method, that the maximum number may come from the arts faculty? Because the lottery method is a lottery, everyone has equal probability. Now, there is a possibility that 70 may come from the arts, 20 may come from the science, and 10 may come from the commerce. None student comes from the law faculty. Now, if this situation occurs, then my population, my sample will not be representative of my population, because here the population is heterogeneous. So, what to do? What is the solution? The solution is that in such case, first of all, we will find the proportion of each group according to their size. Now, total population is 1000, art students are 400, sample I am to take 100. Clear? So, if we see, the proportion of arts faculty will be 40, proportion of science will be 30, commerce 100, law will be 20, 100, add it up, it will come 100. Now, what I will do? I will make slips, 400 slips of the arts faculty, and then pick only 40. So, those 40 students randomly will come for my sample. Then I go to the science faculty, 300 slips, and I will choose only 30. Now, 100 from the commerce faculty, choose only 10. Then law students 200, choose 20. Now, if I do this, my sample will be random and it will represent each subgroup, each strata equally as per their number. This technique is called as the stratified random sampling. Now, when sampling is stratified, standard error formula for the mean differs significantly, for the SEM some little bit changes. Now, that was simple random, standard error mean upon under root n, because the population was homogeneous. When population is heterogeneous, the formula to calculate standard error mean will be little bit modified. It is standard error mean is equal to standard deviation square minus standard deviation s square upon n under root. Now, what is s? Standard deviation of the entire sample. Entire means arts, commerce, science, law, calculate the SD of the all. Now, standard deviation s. standard deviation of the means of the various strata around the mean of the entire sample. Now, it will be standard deviation first is standard deviation independently of age group, and standard deviation S is the standard deviation of each strata keeping the n of the entire 1000 entire sample. We will calculate the standard deviation of the entire sample. So, it will tell you the standard error of mean in the case of the stratified. A convenient formula, if the stratas are more, it was the example of 2, suppose it is more, then the formula will be n1 bracket m1 minus m2 square plus n2 m2 plus minus m square plus dash dash dash, what are the number, nk upon mk minus m square. Now, here you know n stands for, n and m are the size and the mean of the whole sample. N is the sample size of the whole sample which you have taken, and m is the mean of the whole sample. M1 is the mean of the first strata, M2 is the mean of the second strata, Mk, what is the number, 3, 4, 5, 6, whatever they are, you can go on adding. So, N is the total sample, M1 mean of the group arts, science, commerce, law, M mean of the entire group. So, in this way we can calculate the standard error of mean in case of the stratified random sampling. Now, suppose I have given an example just to explain you. Suppose in a sample size of 400 cases, there are 8 subgroups are the strata which vary in size from 70 to 25. The size may be 70 to 25. The mean of the whole sample is 80 and SD is 15. Whole sample mean is 80 and SD is 50. Now, the SD of the mean of 8 groups by the second formula around the general mean of 80 is 5. As I told you, we have to calculate around the entire sample. Now, substituting respective value, the standard error of mean will be 15 square. What is 15? 15 is the standard deviation minus standard deviation total, that is the 5 square upon total. So, in this way you will calculate the standard error of the mean. Now, see, if we use the earlier formula, we will have to calculate standard error mean of the age group, but if we use the second formula, then it will be more convenient and you will know the standard mean of the stratified random sampling. Now, size of the sampling. The dependability of a mean and standard deviation, this is SD, standard deviation, contingent upon the size of the sample upon which the standard error is based. Standard errors vary inversely as the square root of a sample size, so that large the n in general, the smaller will be the standard error of mean. A small sample is often satisfactory in an intensive laboratory study in which many measurements are to be taken upon each subject. But if n is less than 25, say, there is often little reason of believing such a small group of persons to be adequately descriptive of the any population. This has been specifically mentioned by Henry Garrett in 1981. There is a book of the Garrett, Statistics in Education and Psychology. Now, what message this para conveys? It conveys that if you talk about the size of the sample, what should be the size? Larger the sample, lesser will be the standard error of the mean. I have told you earlier also. Small the size of the sample, more will be standard error of the mean. If the standard error of mean is higher, then that mean sample will not be truly representative of the population. But in some cases where we are to use the extensive study, exhaustive study, we can't take a larger group. Here we take a smaller group for the laboratory study, for the extensive study. But Garrett says that even in such cases, in no case sample should be less than 25. So, that means moderate sampling is 25, but it again depends on your study. Even there are researches which have been reported on a single subject, and that is exhaustively done for the years together. So, this was about your standard error of mean, about the random sampling. So, we talked about the type of the probability sampling. I made clear what is the population, what is sample, then random sampling conditions. When it is the biases don't appear, everyone has equal chance of being selection. Selection of one will not affect the other. Then we talked about the number of methods. Then we talked about the how to calculate the standard of mean, and in heterogeneous how to calculate the take the sample. We will first calculate the proportion of each group, and then applying the random technique we will use it. So, this was about your random sampling. Now, the second type of sampling is called as the probability sampling. Now, that we will talk about later on, because it will not be possible to cover in this. Now, here I am to simply sum up. When you calculate when we will come on the statistics, you will see we will carry the T, CR, and there the standard error will appear. Standard error of mean which we are talking about here is nothing. It is simply because a sample is a representative of population. Suppose the population is 1000, and I say in sample is 100. If I say 50% people out of 100, 50 number are in favor of this, their opinion is positive about the policy which you are investigating, then I will assume that this 50% is a population. The results of the sample are generalized on the population, but in doing so there may be some error. So, standard error of mean only calculates what is the extent of error when we assume the mean of the sample equal to the mean of the population. If the standard error of mean is zero, it means there is no error in assuming sample mean equal to the population mean. That means that will be equally representative of the population. So, this was about the random sampling technique, probability sampling. So, in next lecture we will talk about the non-probability sampling. Thank you very much.